Hi and a very good day. So for this video session, I will continue discuss one of the special type of process under stationary series, which is what we call it as white noise process. Okay, so before this, instead of we discuss about the observation, okay, yt as our random variable. Okay, we now look at the probabilistic characteristic of our random error. Okay, so we say that okay, our error term here okay is randomly generated from a population and is assumed to be independent and normally distributed variables with mean 0 and variance equals to sigma square of sigma square. Okay, so this is definition of white noise process. Okay, and by defining our error term has have this probability characteristic. Okay, we say that by having a zero mean, okay, by taking the expectation on both side of the white noise process, okay, this is what we call it as a white noise process. Okay, yt equals to the constant value plus the error term, where the error term here have okay iid okay 0 sigma square. Okay, so this is what we call it as white noise process. So by having a zero mean, by taking the expectation on both side of the white noise process, it will generate the okay a constant value. Okay, so we say that the random error has no effect on the expectation value of the variable y. Okay, and by having a constant variant, we say that the homoscedasticity is whole for every random error, and each random errors are unrelated because when we're talking about time series, the time series itself is a sequence of observation, and this particular observation have their own error terms, and we want our error term to be unrelated to each other, and this particular random errors are generated from the same population. Okay, it is called by white noise process. It is actually an analogy with with white light when and indicates that all possible periodic oscillation are present with equal strengths. Okay, for this particular terms, you can further research okay why we say it is a white noise process, and this white noise process is actually a special case of a stationary time series, and this is actually the most clean or fundamental time series. Okay, because when we say that our error term now have a white noise, okay, many useful model or processes can be constructed based on this particular characteristic, and of course we judge a model as a good fit if the residual error appear to be the realization of the independent variables. Alright, so I have this example here. We have two stationary time series. One is white noise and another is stationary but not white noise. And of course practically it is actually hard to distinguish between these two process. Okay, what we can do, there are actually statistical tests that can be used to distinguish this one from the other. Alright, so I think that's all for this video session. Thank you for listening. Bye.